Today's lesson is on continuous random variables. Before we define a continuous random variable, let us recall the discrete random variable. So what is a discrete random variable? A discrete random variable x takes any one value from a set of values which is finite or countably infinite, each with an associated probability. In other words, discrete random variables are variables which are countable. But for a continuous random variable, the variables take any value in a given range. So see the difference? And in theory, the random variable can be measured to any desired degree of accuracy. So continuous random variables are random variables which are measured. Example, the mass in kilogram of a man, the height in meters of a woman, the distance in kilometers traveled by a car. A continuous random variable x is defined by its probability density function, which can be shown by a curve y equal f of x for a specific domain of x. For example, here we have a curve y equal f of x. The curve is known as the probability density curve, and the area under the curve represents the probability. Hence, the probability that x lies between A and B can be expressed as the probability of x between A and B is equivalent to the integral of f of x from xa to xb, because the method in calculation the area under the curve is to find the integration within the given limits. Okay, so this is known as the probability density function of a continuous random variable. Please take note. The probability density function f of x has the following characteristic. All probabilities are non-negative. B, the total area is 1, or the area under the curve is 1, or the sum of the integral is 1. Take note that it doesn't matter how you write the inequality sign. It can be both inclusive or partly inclusive or non-inclusive. If we look here, point number 2, Px between A and B inclusive can be written as Px between A and B A inclusive, or Px between A and B B inclusive, or Px between A and B non-inclusive. Okay, this is because x is a continuous random variable. But notice that when Px equal A at a point, the probability is 0 because at a point, the area is 0. Let's look at the first example. You're given the function, but the question does not state whether it is a continuous random variable or a discrete random variable. We look at the function. Notice that the values of x is given in an interval. For example, the first one, fx equal x squared, the value of x lies between 0 to 1. F of x is 1 for x lies between 1 to 5 over 3, 0 otherwise. So from here, we know it's a continuous random variable. Why? Because the value of x lies in a given range. So first part of the task is that you have to show f is a probability density function and later find px between 1 over 2 and 3 over 2. Part A. You are required to show that the function f of x is a probability density function. So notice that for all values of x in the interval, your f of x are non-negative. Next, you have to show that the sum of the integral of the function must be 1. In other words, the total area is 1. So for the function x squared, the limits are from 0 to 1. For the function 1, the limits are from 1 to 5 over 3. So you integrate x squared, you have x cubed over 1. You integrate 1, you have x. So you substitute the upper and lower limits, you have 1. Now, since the question asks you to show or prove, hence you have to make a deduction. Therefore, f of x is a probability density function. Part B, finding the probability of x from half to 3 over 2. You look at the function. Okay, your x half lies in the interval 0 to 1. So you have to use the function x squared. 3 over 2 lies in the interval 1 to 5 over 3. So you have to use f of x equal 1. Okay. So write down the function with its correct limits. You integrate with the limits. You substitute the limits and you have 19 over 24. So make sure you know how to integrate. Example 2. Okay, you are given a continuous random variable x that has the probability distribution function f of x. Okay, so you need to find the value of k, sketch the graph of f of x, find the probability of x from 1.5 to 2.5, and find m if the probability of x less than equal m is 0.5. Okay, to find k, we use the concept that the area under the curve must be 1. In other words, the sum of the integral is 1 because f of x is a probability density function of a continuous random variable. Okay, so the integral of k 6 minus x from x0 to 3 must be 1. You can take out your k because it's a constant. So you just integrate 6 minus x. So you have 6x minus x squared over 2. You substitute your limits 3 and 0. So you have 27 over 2k is 1. Hence your k is 2 over 27. For part B, you are required to sketch the graph of f of x. So look at the function f of x. You have 2 over 27 times 6 minus x. Clearly, this is a linear function. So what is the shape of a linear function graph? Yes, it is a straight line graph. So to draw a straight line graph, you need to have at least 2 points. So we choose x 0 and 3. When x is 0, f0 is 4 over 9. When x3 is f of 3 is 2 over 9. So plot the points. When x is 0, f of 0 is 4 over 9. When x is 3, f3 is 2 over 9. Okay, although the question asks you to sketch, you still need to use a ruler to draw the straight line. You don't have to use the graph paper because the question asks you to sketch. Part C, you are required to find the probability of x from x 1.5 to 2.5. Okay, now I have already shaded the area under the line from x 1.5 to x 2.5. So to find the area, you can use integration from x 1.5 to 2.5. So you integrate the function 2 over 27, 6 minus x. Okay, once you get the integral, you substitute the limits, you simplify, so the value is 8 over 27. So in other words, the probability of x from 1.5 to 2.5 is 8 over 27. Now, if we look at the shape under the line, it has a trapezium shape. So we can use the trapezium law to find the area under the line. But first, you need to find the value of f1.5 and the value of f2.5. And using the trapezium formula to find the area of the shaded region, so half the width 2.5 minus 1.5 and the sum of the parallel sides. So you have 8 over 27. Part D, you are supposed to find m given that the probability of x less than or equal m is 0.5. Okay, so using the same function, now your limits is from x0 to m. You integrate and you substitute the limits m and 0. Okay, simplify, you have a quadratic equation 2m squared minus 24m plus 27 is 0. Okay, solving, m is 1.257 or m equal 10.74. Now, which value of m are you going to choose? Are both accepted or only one of them is accepted? So if you look at the range of values of x of the function, your x only lies between 0 and 3. So obviously m equal 10.74 is not accepted. So we can just write that ignore. So the value of m is 1.257. Now, look at your textbook, exercise 3.4, question 3. Question 3 says that y is a continuous random variable with probability density function as shown in the slide. So you need to calculate the probability of y less than 1 and the probability of the modulus y less than 3 over 2. Okay, we look at the first part. The probability of y less than equal 1. So you look at the function, negative 2 to 1. Obviously, we have to use the first function, 3y squared over 16. So you integrate y cubed over 16 from y negative 2 to 1. So the probability is 9 over 16. Okay. Part B, when you open up the model sign, so your y, because we have p modulus y less than 3 over 2, so when you open up the model sign, your y lies between negative 3 over 2, 3 over 2. So you recall back what we did in term 1. Okay. If you have forgotten, you refer back your notes in term 1. So find the integral of the function 3y squared over 16 from y negative 3 over 2 to 3 over 2. You integrate, you have y cubed over 16. You substitute the limits, so the probability is 27 over 64. Now look at question 6. Okay, question 6 states that x is a continuous random variable. Okay, the function is given here. So determine the value of the constant k and then find the probability of x between -1 and 1 and find the probability of x greater than 1. Okay, so we do the first part. To find the value of k, again we use the concept that the total area under the curve is 1. In other words, the sum of the integral is 1. Okay, the first integral is from -2 to 0. So the function is kx plus 2 squared. The second integral is 4k from x0 to 4 over 3, and the sum must be 1. Okay, you integrate. The first one is a composite function, so the integral is x plus 2 cubed over 3. Okay, the second one is 4x actually, from x0 to 4 over 3 equal 1. Okay, substitute the limits. Your k is 1 over 8. So once you find the value of k, now we do part A, finding the probability of x between -1 and 1. So substitute k as 1 over 8 in your function. So -1 to 0, the function is x plus 2 squared over 8. From 0 to 1, the function is half. You integrate, you substitute the limits, so you have 19 over 24. So here, in finding the probability of a continuous random variable, you must be skillful in integrating. So if you feel that you are not familiar with the integral rule, you look back in your Term 1 notes. Finding the probability of x greater than 1. So we only have x from 1 to 4 over 3. So you integrate, you have this. Substitute, so the probability of x greater than 1 is 1 over 6. Okay, straightforward if you know how to integrate. Okay, now let's look at the example. Let's look at the third example. Okay, this time you're given a diagram that shows a sketch graph of the probability density function of a continuous random variable x. So find the value of a, hence you define the probability density function of f of x. And then calculate px greater a over 2. Okay, so how do you find the value of a? The total area under the graph is 1. So first is a triangle. Half time base is a, height 1 over 3, plus a rectangle. The width is 4 minus a, the length is 1 over 3. So the total area must be 1. So solving, you have a over 6 equal 1/3. So your a is 2. So to define your f of x, okay, you look at the range of values of x from 0 to 2. The equation of the straight line is f of x 1 over 6x. Again, make sure you know how to get the equation of the straight line. And from 2 to 4, the equation of the straight line is just 1 over 3. So when you define your f of x, the first one is 1 over 6x from x0 to 2, 1/3 from 2 to 4, and 0 otherwise. Okay? Right, for part B, you need to find the property of x greater a over 2, which is property of x greater than 1. So if you were to look at the graph, x greater than 1 is partly the area of the trapezium plus the area of the rectangle, so which is quite tedious. It's easier to use the integration. So we use 1 minus px less than equal 1, which is 1 minus 1 over 6x from x0 to 1. Okay, you integrate, you substitute, and you have 1 over 12. Okay, class, that's all for today on continuous random variable.